Guest is with us now. I welcome Dr. Kiran Tajne ma'am, Professor and Head Civil Engineering Department, Government College of Engineering, Nagpur, on her third lecture on the topic fluid mechanics under AICT sponsored Prerna scheme. Ma'am, I request you to now please take over the session.
Thank you, sir.
Thank you, ma'am.
Okay. Good afternoon, everyone. Am I audible, Asif
Yes,
sir?
ma'am. Yes, ma'am.
Yes.
Yes, ma'am.
And
Yes,
PPT is visible.
yes, yes, ma'am.
Oh, so today's topic is channel hydraulics. It is related to fluid mechanics. So today we'll cover what is open channel, what are the types of open channel, then what are the types of flow, channel geometry, energy depth relationship, types of flow. Actually, it is repeated. Then specific energy, then critical, subcritical, and supercritical flows, and slope profiles, and then a hydraulic jump. So this is again a vast topic, but I'll try to cover in 1 hour. So let us start. What is open channel? So open channel are the natural or man-made conveyance which has a free surface at atmospheric pressure. You have seen the canals. These canals are nothing but the open channel. These are there are various types, but this trapezoidal type of channel is most popular. So the examples are flume. It is flume is a channel which is made up of wood or metal or concrete masonry, usually supported on or above to carry out the water across a depression. Then chute. It is again a channel having steep slopes. Drop is similar to chute but change in elevation. Then culvert is again a type of open channel. When partially filled, it is covered with which is covered channel and installed to drain water through highways or railway embankments. Okay. So these are some examples of open channel. Now we'll see what are the different types of channel. There are various types. So prismatic and non-prismatic channels. So prismatic channel is a channel in which cross-sectional shape, size and bottom slope are constant. In which cross-sectional area, shape, size and the bottom slope is constant. That is known as prismatic channel. Then all natural channels generally having very varying cross section, and these are called as non-prismatic channels. So most of the man-made channels are prismatic channel because it has definite shape, size and slope. Therefore that is called as a prismatic channel. And rectangular, trapezoidal, triangle, circle, these are the commonly used shapes in man-made channels, which are called as prismatic channels. Okay. And non-prismatic are the natural channels. Next is the rigid and mobile boundary channels. So rigid channels are those in which a boundary is not deformable. The shape and roughness magnitudes are not functions of flow parameters. For example, line canals. Line canals means one concrete layer or masonry layer is provided on the original earthwork. Okay, so that lining is provided, therefore it is called as line canals. These are called rigid channels. Shape, roughness, magnitudes are not functions of flow parameters. And in rigid channel, the flow velocity and shear stress distribution will be such that no major scoring, erosion, deposition will takes place in the channel. And channel geometry, roughness are essential constant with respect to time. So when the boundary of channel is mobile, that means flow carries considerable amount of sediment through suspension and is in contact with the bed. Such channels are classified as mobile channels. So in mobile channel, not only depth of flow but also bed width, longitudinal slope of channel may undergo changes with space and time, or it depend upon the type of flow. Okay, so these are called as mobile channels, mobile boundary channels. Then resistance to flow, quantity of sediment transported, and channel geometry, these are dependent on interaction of flow with the channel boundaries. So general mobile boundary channel can be considered to have 4 degree of freedom, and in rigid channel we have 1 degree of freedom. We have studied this in structural analysis, what is degree of freedom. Okay. So these are called rigid and mobile boundary channels. So there are different types of flow, steady and unsteady flow. In fluid mechanics 1, we have already studied these types of flow. So these are also called as flow regimes. So the steady flow occurs when the flow properties such as depth or discharge at a section do not change with time. If the depth or discharge changes with time, then it is known as unsteady flow. So in steady flow, flow properties such as depth or discharge at a section do not change with time. So flood flows in rivers and rapidly varying surges in canal are some example of unsteady. Unsteady means where depth or discharge changes with time. So river flood flows in river. These is term as unsteady flow. Okay. Then next is the uniform and non-uniform flow. So when flow properties, say depth of flow in open channel, remain constant along the length of channel, then the flow is said to be uniform. Okay, when the depth of flow in the open channel remain constant along the length of channel, then it is termed as uniform. A flow in which flow properties vary along the channel, then it is termed as non-uniform flow. Means where depth of flow varies along the length of channel, then it is termed as non-uniform flow. A prismatic channel carrying a certain discharge with a constant velocity is an example of uniform flow. So in uniform flow, the gravity force on the flowing liquid balances the frictional force between flowing fluid and inside surface of the channel, which is in contact with the fluid. Okay, so in case of non-uniform flow, the friction and gravity force are not in balance. Okay, here you can see the figure uniform flow through open channel. Okay, here depth y Y shows the depth of flow. So at suppose left hand side, this is inclined line, and this inclined line, dark line shows the bed slope over which the water or fluid flow. So the depth Y is constant uh, throughout the length of the channel. Therefore, it is known as uniform flow. If it is varies, then it is known as non-uniform flow. So there are two types of non-uniform flow: gradually varied flow and rapidly varied flow. So if change of depth in varied flow is gradual, so that the curvature of streamline is not excessive, then it is in case of, then it is called gradually varied flow, isn't it? When the curvature of streamline is not excessive and there is change in depth gradually, then it is called as gradually varied flow. And if the curvature in a varied flow is large, here it is given y1 and y2 are different. So when curvature in a varied flow is large and the depth changes uh, over short length abruptly, then such flow is known as rapidly varied flow. Okay. So, sorry. So in figure, water surface profile of gradually varied flow y1 and y2 are the depth at section 1 and 2 respectively. So in gradually varied flow, loss of energy is essentially due to boundary friction. Therefore, the distribution of pressure in the vertical direction may be taken as hydrostatic. Okay. Then we'll see spatially varied flow. What is a spatially varied flow? If some flow is added to or subtracted from the system, then the resulting varied flow is called spatially varied flow. SVF is nothing but the spatially varied flow. It can be steady or unsteady. So in steady varied flow, the discharge while being steady varies along the channel length, and the flow over a side weir is the example of a steady flow. So this shows the spatially varied flow. Now we will see what is channel geometry, how the channel is, open channel is. Okay. So the term channel section means cross section of channel taken normal to the direction of flow. If suppose the direction of flow is this, then we can cut. Section means cut. Here, if we cut or if you provide a section, then that trapezoidal part will be shown, and that is called as cross section of channel. So the vertical channel section is the vertical section passing through the lowest or bottom section. So the natural channel sections are in general very irregular in shape, whereas artificial channels such as prismatic channels are designed with sections of regular geometry shape. So throughout the length, you will find the same shape. If it is trapezoidal, then you will find trapezoidal shape. So trapezoid is a commonly used shape. Rectangle, triangle are a special case of trapezoid, and since the rectangle has vertical sides, it is commonly used for channels built of stable material. such as lined masonry, rock, metal, or timber. Okay, here there are some nomenclatures. So depth of flow Y is the vertical distance from the water surface to the lowest point of the channel section. Here there are some alphabets written. This small y is nothing but the depth of flow, and it is vertical distance from the water surface to the lowest point of the channel section. Then capital T. Capital T is the top width, and the it is the width of natural section at the water surface. Then A is the water area, which is cross sectional area of flow measured normal to the direction of flow. Just I have told you, which is vertical cut normal to the direction of flow. Capital P is called weighted perimeter, which is the length of intersection of channel line of intersection of channel weighted surface with the cross sectional plane normal to the direction of flow. Then capital R is hydraulic radius. It is the ratio of water area to the weighted perimeter. A by P. R is equal to A by P, where A is area, cross-sectional area, and capital P is the weighted perimeter. Then hydraulic depth is denoted by D. It is the ratio of water area to the top width, capital A upon capital T. Then section factor Z for critical flow competition. It is the product of water area and the square root of hydraulic depth. A into under root D. And in case of uniform flow section, it is given by 2/3. Okay. So these are some of the nomenclatures for open channel. So for rectangular channel, this is rectangular channel. Its vertical sides, the sides are vertical and bed slope is horizontal. There is a slope, bed of the channel is horizontal. So weighted perimeter will be B plus 2y, twice y. Both the sides, top width T is equal to B and hydraulic radius R is equal to B into y by B plus 2y. So in short, we'll cover these expressions. So for triangular, R is equal to my by twice under root 1 plus m square, where m is the side slope. Side slope can also be denoted by small n. Okay. So in trapezoidal section, P is equal to B plus twice y under root 1 plus m square. Top width is B plus 2my. And radius is hydraulic radius is B plus my into y upon B plus twice y under root m plus 1 plus m square. So these expressions or derivations will not cover in today's lecture. We'll focus on the basic concept of these important parameters. Okay. So now we'll study what is a specific energy. So specific energy is the energy head. What is energy head? It is addition of datum head plus potential head plus kinetic head. Here in figure it is shown if a datum is AB and there is difference between datum which we have taken and the datum is an imaginary line. Okay. And the channel bottom, channel slope. Okay. So from datum to channel slope, the vertical distance is known as datum head. Then, then channel bottom to water surface. Water surface is means depth of flow. It is denoted by Y. It is also known as potential head or potential energy. And then above that there is energy gradient line which is parallel to the water surface, and that distance is known as kinetic head. It is actually kinetic velocity v square by 2g. Okay. So it is in terms of meter. Energy is in terms of meter or head. So that v square by 2 is nothing but the velocity head. So this specific energy is the energy head relative to the channel bottom expressed in terms of flow depth and velocity head. Okay. Here in figure, datum head is also shown. Most of the time, the channel bottom is considered as datum. So in that case, the Z will be 0. Therefore, we have to consider only two parts. That is why depth of flow, potential energy and kinetic energy v square by 2g. Therefore, the specific energy, here it is written when channel slope is very small, then specific energy is equal to y plus v square by 2g. Okay. Then if the channel having a large bottom slope, then the specific energy is given by y cos theta plus v square by 2g, where theta is the angle between channel and the horizontal line. Okay. So horizontal, if horizontal makes an angle of theta with the channel bottom, then its vertical component will be y cos theta. So it is y cos theta plus v square by 2g. Okay. So when the depth of flow is plotted against specific energy for a given channel section and discharge, the specific curve is obtained. And for that specific energy, there are two possible depths, H1 and H2. Here it is mentioned H1 and H2. Okay. At A, it is H1 and at B, it is H2. Clear? And these two depths are called as alternate depths. H1, H2 are called as alternate depths. So minimum specific energy corresponds to critical state of flow. Minimum specific energy corresponds to the critical depth of flow. So here this curve shows the discharge curve shows the or graph is between discharge and the specific energy. Here at the curve line there is minimum specific energy. So minimum specific energy means there is maximum discharge. Okay. So Q max occurs at critical depth for any other two discharge alternate depths. Okay. So here there are three flows are showing: subcritical flow, critical flow and supercritical flow. So here when the critical depth is greater than the uh, flow depth, then it is known as supercritical flow. So Froude's number is greater than 1. For subcritical flow, Froude's number is less than 1. Okay. So for discharge to be maximum, the specific energy should be minimum. And for maximum discharge occurs when y is equal to 2 by 3 E, where y is the depth of flow and E is the specific energy, and it will be minimum specific energy. So for maximum discharge, when y is equal to 2 by 3 E, then there will be maximum discharge, and flow beyond the Q max is not possible. Okay, so the maximum discharge occurs at critical depth, and for any other discharge, two alternate depths are possible. One will be below critical depth, and another will be the above critical depth. Okay. So when the depth of flow is greater than critical depth, the velocity of flow is less than critical velocity of that flow, then it is called subcritical flow. And when depth of flow is less than critical flow, then it is supercritical flow. Okay. Now we'll see what is critical flow. So we have seen what is critical depth. Critical depth is the depth at which specific energy is zero. Okay. So the critical flow is the critical state of flow is defined as the condition for which Froude's number is equal to unity. So the most common definition is that the state of flow at which specific energy is minimum for a given discharge. So critical slope is the slope such that normal flow occurs with Froude's number equal to 1. Okay, when Froude's number is equal to 1, then that flow is known as critical flow, and that depth is also known as critical depth. Okay, the smallest critical slope for a specified channel shape, discharge and roughness is termed as limiting slope, and the equation for a specific energy in channel of a small slope is given by E is equal to y plus, we have seen v square by 2g, and v is equal to what is v? Velocity. So uh, discharge is equal to velocity into area. Okay. So from that we can calculate the specific energy in terms of discharge. So y is equal E is equal to y plus q square divided by 2ga square. Okay. So since v is equal to q by a, it is written in terms of q and area. This is critical flow. Now we'll see what is subcritical flow and supercritical. We have just mentioned this. When depth of flow in a channel is greater than critical depth, then it is termed as subcritical or streaming flow. Here Froude's number is less than 1. And for supercritical flow, which is also known as shooting flow, so when depth of flow is in the channel is less than critical depth, or Froude's number is greater than 1, then it is termed as supercritical or shooting flow. Okay. So here there are some equations, and it is the velocity is calculated by Manning's formula and Chase's formula. Okay. So here there are a number of expressions in the specific this open flow channel. So the critical flow is calculated for here rectangle channel. For rectangle channel, we'll go to end only. This is one of the case that I have taken. For rectangular channel, specific minimum specific energy is 3 by 2 Yc. Yc is the critical depth. Okay. Earlier we have seen Yc is equal to 2/3 of E minimum. That formula is also correct. From that formula you get Yc, and from this formula you get E minimum, that is specific energy which is minimum from the depth of flow. Okay. Then what should be the qualification of uniform flow if we have to study the open channel? So the criteria for uniform flow must be known. Clear? So the uniform flow has the two features, main two features: the depth, water area, velocity, and discharge at every section of the channel are constant. Okay. Then energy line, water surface, and bottom channel bottom, these are parallel to each other. Means their slopes are equal. So SO, which is the slope of channel bottom, is equal to SW, slope of water surface, which is equal to SF, which is the slope of energy line. So all these three slopes are equal to S. They are parallel to each other. So uniform flow has constant velocity at every point on channel section, and the depth, flow depth in uniform flow is known as normal depth. Then uniform flow is always steady. Okay. Uniform flow is always steady. Because the uniform flow is always steady, because the unsteady uniform flow practically never occurs. However, the turbulent uniform flow does occur, but practically unsteady uniform flow never occurs. So when flow occurs in open channel, the resistance is encountered by water as it flows downstream. So this resistance is generally counteracted by the component of gravity forces acting on the body of the water in the direction of motion. So the uniform flow will be developed if resistance is balanced by the gravity force. Clear? So uniform flow will be developed if resistance is balanced by the gravity forces. Okay. If the water enters the channel slowly, the velocity and hence the resistance are small, and this resistance is balanced by the gravity forces. Okay. So this resistance will gradually increase until a balance between resistance and gravity force is reached. And at this moment or afterwards, the flow becomes uniform. Clear? So the upstream reach that is required for the establishment of uniform flow is known as transitory zone. And in this zone, the flow is accelerating and varying. Suppose if the channel is shorter than the transitory length required by given condition, then the uniform flow cannot attain. The length of transitory zone depends on the discharge and the physical condition of the channel. such as entrance condition, how is the slope of that channel, how is the shape and roughness. So this length of transitory zone is depending on these physical conditions. So the prismatic channel carrying a certain discharge with constant velocity. Prismatic channel is an artificial channel or man-made channel carrying a certain discharge with constant velocity, is an example of uniform flow. Okay, so these characteristics should be in the water flow, which is known as uniform flow. Then the velocity is measured, velocity of flow is measured by Manning's equation. We all know V is equal to 1 by n r to the power 2 by 3 and s to the power 1 by 2, where V is the mean velocity, r is the hydraulic radius, and s is the slope of energy line, and small n is the coefficient of roughness. Okay. Then this Manning's formula is commonly used. Changes, we can also calculate velocity from the Chase's formula. Okay, all these formulae are known to you, and these are very common. Next, we'll see what is most economical section. Most economical section means where the discharge is maximum. It is also known as best hydraulic section. Okay. So it is known that the conveyance of the channel section increases with increase in the hydraulic radius or decrease in the weighted perimeter. So from hydraulics viewpoint, the channel section having least weighted perimeter for a given area which has maximum conveyance. Such section is known as best hydraulic section or most economical section. So of all the possible open channel section, the semicircular shape has the least amount of perimeter for a given area. Okay. So here you can see the most economical channel section. So for a rectangular channel to be most economical, the condition is that B, bottom width, is equal to twice YC, where YC is the critical depth, and R is equal to YC by 2. Similarly here for trapezoidal section also the formulae are given. So these hydraulically the most efficient trapezoidal section is 1/2 of the regular hexagon. Okay, the dimension of hydraulically efficient trapezoidal section will be such that the semicircle can be inscribed in it. Okay, so that is called as most economical trapezoidal section. Now we'll see what are the water surface profiles, different water surface profiles or slope profiles. Okay, so the water surface profile is a measure of how the depth of flow changes longitudinally. Longitudinally means along the length of the flow. So the profiles are classified on the basis of the relationship between actual water flow, which is denoted by small y, the normal depth, which is denoted by yn, and critical depth yc. Okay, so the normal depth is the depth of flow that that would occur if the flow was uniform or steady. If the flow is uniform or steady, then the depth of flow occurs, and that is known as normal depth. Then critical depth. Critical depth is the depth of flow where energy is at a minimum for a particular discharge. Okay, we have already seen this. What is critical depth? So YC is the critical depth where energy is minimum, and these uh, depths is usually predicted using Manning's equation. Just now we have seen V is equal to 1 by n r to the power 2 by 3 s to the power half. Okay. So there are different water surface profile depending on the yn, that is normal depth, and critical depth. There are different surface profiles which are classified as mild slope, which is denoted by M, critical slope C, steep slope S, then horizontal slope H, and adverse slope is denoted by A. Okay. So the channel bottom slope is designated as critical when the bottom slope, here it is written bottom slope is denoted by SO or S0. So SO or S0 is equal to critical depth or critical slope. Sorry. When bottom slope is equal to critical slope, then it is termed as critical slope, or here the normal depth of the flow is equal to the critical depth, that is called as yn is equal to yc. Similarly, what is mild slope? Mild slope is when, sorry, bottom slope S0 is less than SC, that is critical slope. S0 is less than SC, then it is mild slope. Here yn, normal depth, is greater than yc. Clear? Then there is a steep slope. Steep slope means when bottom slope S0 is greater than critical slope. In mild slope, yn is greater than yc. Here in steep slope, yn is less than yc. Normal depth is less than yc, but S0 bottom slope is greater than a critical slope. Then it is termed as steep slope. Then next term is horizontal slope. Horizontal slope means the bottom slope is 0. It is just horizontal. SO is equal to 0. When SO is 0, then yn is infinite. Depth, normal depth is infinite. Okay. Then that is known as horizontal slope. Then last one is the adverse slope. When the channel bottom slope, instead of falling, rising in the direction of flow, then S0 is less than 0. In adverse slope, S0 is less than 0 and yn, that is normal depth, is imaginary. Then this is called as adverse slope. The channel bottom, instead of falling, it rises in the direction of flow. Then it is called as adverse slope. So, depending upon the criteria, here we can say that for mild slope, criteria is yn greater than yc. Just we have seen. That means the sustaining slope, that is falling in the direction of flow. Okay. In critical slope, Yn is equal to Yc. Here again, sustaining slope is in the direction of flow. Then for steep slope, Yc is greater than Yn. Critical depth is greater than normal depth, or normal depth is less than critical depth. Here also the slope of bed is in the direction of flow. And in fourth case, horizontal slope SO is 0, just we have seen. Okay. So this Yn is prediction of this Yn is very difficult. So we cannot get the relationship between Yn and Yc. Okay, here Yn is, because Yn is infinite. Therefore, it is written that non-sustaining slope Yn does not exist, or it may be infinite. And for adverse slope, SO bottom slope is less than 0. Less than 0 means it is again non-sustaining slope. It is rising in the direction of flow. Okay. So depending upon these levels, critical depth, normal depth, and actual flow, there are 3 zones. So the entire region above the channel bottom is divided into 3 zones by drawing 2 lines in longitudinal direction above the channel bottom. So one line will be of critical depth, CDL, critical depth line, which shows YC, critical depth, and another line will be the normal depth line, which shows the normal depth, YN. Okay. So the zone 1 refers to the region lying above the uppermost line. Above the uppermost line means NDL, normal depth line. Then zone 2 refers to the region lying between uppermost line and the line next to it, means CDL, critical depth line. In between NDL and CDL, there is zone 2. And below that, the region between middle line, that is CDL, and the channel bed line is known as zone 3, which denotes the YC. So here there are 3 profiles. For case 1, Y is above the normal depth line. Okay, so Y is greater than YC, which is greater than YN. Sorry, YN greater than YC. So Y is greater than Yn greater than Yc. So this M1 shows the mild slope for this first condition. In second figure, you will see the slope is in second zone, zone 2, between CDL and NDL. Okay. So the whenever water flows from a starting point through the longitudinal direction, the depth of water is reducing. This curve shows that the depth of water is reducing. Okay. So here the condition is that Yn is greater than Y, which is greater than Yc. It is M2 type of curve. Yn is greater than Y, which is greater than Yc. Okay. So in third case, Y is in or slope is in third zone. So here Yn is greater than Yc, which is greater than Y. Y is the slope of curve, actual depth of flow. Okay. So in third condition, Yn is greater than Yc, which is greater than Y. So similarly, we can go for the another slopes, critical slope. In critical slope, there are again 3 conditions. C1, C2, C3 will get. So here in for critical slope, normal depth and critical depth line are same. So yn is equal to yc, and C1 occur in third zone, uppermost layer. So y is greater than yn or yc. Okay. Then C2 does not exist, um, because zone 2 does not exist in the critical slope condition. Okay. Zone 2, why zone 2 does not exist? Because normal depth line and critical depth line are same. Then for third condition, there is slope 3 which occur between normal depth line or critical depth line and bed slope C3. So if for case of C3, Yn or Yc, these are same. Yn or Yc is greater than Y. Then for steep slope, it is just opposite to the mild slope. Steep slope is just opposite to the mild slope. Okay, so here again S1 shows the steep slope for first condition. S1 is in first zone, zone 1. Okay, so Y is greater than Yn, which is greater than Yc. Then S2 curve is in between zone 2. Here again condition is that Yc is greater than Y, which is greater than Yn. Sorry, here condition is Yn Yn is greater than Y, and which is greater than Yc. Here in between there is Y. So for third condition is that Yn is greater than Yc, which is greater than Y. This is S3 type of steep slope. Again in horizontal slope, for horizontal slope there is only critical depth line CDL. Okay, Yn is infinite, there is infinity, because we cannot measure or predict the that depth in horizontal case, horizontal slope. Okay, so here Yn does not exist ऐसे हम बोल सकते हैं. So above CDL one line must be there, that is NDL, that does not exist. Therefore it comes zone 2. So for first condition there will not be any curve. Okay, so second condition we can see here H2 is in second zone. Okay, so here Y is greater than Yc, we can say that. Then in third condition H3, Yc is greater than Y. Okay, then for adverse slope, the slope is rising in the direction of flow. Yes, it is opposite to the direction of flow. Sorry, in most of the cases, in normal cases, the slope is in the direction of flow. Okay, so here it is rising. In earlier cases, for critical mild and steep slope, the bed slope is falling, and in adverse slope it is rising. Okay, so here again the normal depth line is not shown, there is only critical depth. So first case, that is A1 will not occur. So for A2 it is in between second zone and CDL and above. So yc or y is greater than yc. Yc is less than y. And in for A3, y is less than yc. Okay. Or yc is greater than y, vice versa. So these are the five slopes. So there are five types of slopes and three profiles in zone 1, zone 2 and zone 3. So theoretically we could get 15 surface profiles. Okay. So however, in case of critical slope, NDL and CDL are same. So the what C2 will not appear. Okay. In case of horizontal and adverse channel, first profile C1, sorry, H1 and A1 will not occur. So therefore, it can be concluded that only 12 water surface profiles are possible out of these 15 because of the condition which is given. So the water surface profile which are lying in zone 1 and zone 3. Zone 1 and zone 3 are called as backwater curves. The surface profiles which occur in zone 1 and zone 3 are called as backwater curves. And those which are lying in zone 2 are called as drawdown curves. So there is a difference. Drawdown curve and backwater curve. Backwater curves occur in zone 1 and zone 3 and drawdown curves occur in zone 2 only. Okay. So the hydraulic curve classification are used to describe the shape of water surface profile at a specific flow. So the curves are based on hydraulic slope and the relative position of actual flow depth to normal and critical depth, which are designated by 1, 2 and 3. Okay. So this is about critical slopes, sorry, different types of slopes. So here you can see the different types of water surface profiles, normal depth, then NDL, CDL is the critical depth line. Same I have compiled here. So for M1, M2, M3, for mild steel, all the three slopes will get. For steep slope also, we'll get three slopes, three profiles. For critical depth, C1 and C3 will get, C2 will be 0. And then for horizontal slope, H1 will not occur. Similarly, for adverse slope, A1 will not occur. So C2, H2, oh sorry, H1 and A2, these will not found in this surface profile. So these are the 12 uh, different types of water surface profiles out of 15. So now we'll see what is hydraulic jump. Okay. So this hydraulic jump is a phenomena in which a flow passes suddenly from supercritical flow to the subcritical flow, causing a distinct rise or jump of water. Okay, that is known as standing wave. So we have seen what is rapidly varied flow, what is gradually varied flow. So in a rapidly varied flow, the depth or discharge, these are the flow characteristics, abruptly change with length. So therefore that is known as rapidly varied flow, and this hydraulic jump is the typical example of rapidly varied flow. Okay. So here you can see the flow changes from supercritical to subcritical. So this L L1 is known as the length of jump, and there are two depths, y1 and y2. Y1 is the depth of supercritical and y2 is the depth of subcritical flow. Okay, so here the depth abruptly change, depth of flow abruptly change, therefore it is known as hydraulic jump. So these are some locations where the hydraulic jump may occur. So first is the steep slope meets mild or horizontal slope. When steep slope meets mild or horizontal slope, then the hydraulic jump may occur. Then steep slope meeting to adverse slope uh, means there is increase in slope when we consider length. So it is increasing with respect to length. So steep slope meeting the adverse slope. And here also we can see the it is also a possible location of hydraulic jump. And third case is when hump is provided on the steep slope. Hump means it is a increment in the bed of the channel. It is like some obstruction, or suddenly the there is a slope and there is some increment on that bed of the channel, that is known as hump. Okay, so so these are three cases where the hydraulic jump may occur. So here we have seen same, whenever steep slope meets a mild slope or adverse slope, this may be first condition or location. Then on downstream side of the sluice grade, and on the upstream side where hump is provided on the steep slope. So these are some locations where jump is possible to occur. So why we create hydraulic jump? What should be the reason for that? Okay. So what is the actually use of this hydraulic jump? To dissipate the energy. Okay. So in hydropower, what we do, we use kinetic energy of water to produce electrical energy. Okay. So for hydropower, we use kinetic energy to produce electrical energy. So after producing the electrical energy, if same water means if increased velocity water directly disposed of on the downstream side of a river or water flow, then scoring may occur. Scoring means erosion, soil erosion may occur. Okay, so to avoid that, to avoid the scoring or to avoid the erosion of soil, we have to reduce the velocity of water and then disposed of. We have to reduce the velocity of water and then we can dispose that water on the downstream side. So for that reason, we have to produce the hydraulic jump. There means that means the velocity of water will be reduced. Okay, so that is why the hydraulic jump is provided. So there are two reasons that we have already discussed. So to reduce the speed of the water which is to be disposed into the downstream side of the river after producing electrical energy, and to reduce the scoring and sedimentation or deposition of loose material from the channel. Okay. So here is the classification of hydraulic jump based on the Froude's number. We have already discussed about Froude number. But what is actually Froude number? It is the ratio of square root of inertia force to gravitational force. So when the Froude number ranges from 1 to 1.7, then that jump is called as undular jump. Then weak jump ranges from 1.7 to 2.5 Froude's number. Then if the Froude number is in between 2.5 to 4.5, then the jump is called as oscillating jump. And when 4.5 to 9, for that range, the jump is steady. And above 9, when the Froude number is more than 9, then that jump is called as strong jump. Okay. So, so these are some figures, sketches of different types of jumps. So first figure shows the undular jump. Froude's number is 1 to 1.7. Okay, means small undulation or slight ripples are formed on the surface of the earth. Sorry, surface of the water. Then that jump is called as undular jump. Then second is a weak jump. It is 1.7 to 2.5. And here the small roller surface and energy loss is very low. Okay. In third type oscillating jump, Froude's number is 2.5 to 4.5, and the jet entering the jump oscillates from bottom to top and back again at an irregular period. So the irregular waves which travel a long distance are produced, and these waves may cause considerable damage to the banks of the channel. Then steady jump, it ranges from 4.5 to 9 Froude's number, and it is well balanced and occur at the same location, and the position of the jump is not affected by the downstream water level. So, and the energy loss ranges from 45 to 70%. And in lastly, there is a strong jump, uh, where Froude's number is more than 9. Here, the energy dissipation can be up to 85%. And this in this, the surface is very rough and continue for the long distance. So these are 5 types of hydraulic jumps. So where it is used? It is used as energy dissipator to dissipate the energy of water flowing over the dams, weirs, and prevent the scoring on the downstream side. It is also used to increase discharge through a sluice by holding the water back. Then it is also used to increase the water depth on the apron, and that reduce the uplift pressure. It also used to raise the water level in irrigation canals to increase the command. Then aeration and dechlorination of wastewater. Then to remove the air pockets from the water supply pipes, these hydraulic jumps are used. And it is also used to mix the chemicals thoroughly in the water treatment plant. Okay. So these are some of the practical applications of hydraulic jump. So here we'll stop. If you have any question, you can ask quickly for 2-3 minutes.
Okay, students, the session is now open for question answer. If you are having any doubt, you can ask the question.
I think students are very intelligent. They don't have any problem.
And they don't have any question.
Hmm. Okay, no problem.
Okay, ma'am, no issue. If students have no problem, no query, uh, then we can conclude this session.
Okay. Thank you.
Okay, thank you, ma'am. I have pasted the link for the attendance. Kindly fill the attendance form and then you can leave the class.